In 1945, as World War II came to an end, Soviet engineers were given a rare opportunity to design a tank without compromise. Not a balanced machine, not something intended for mass production, but a vehicle built for absolute battlefield dominance regardless of cost, weight, or logistical constraint. At the center of this effort was Nikolai Shashmurin, a young Soviet engineer tasked with pushing beyond wartime limitations. His directive was simple but unprecedented: create the most powerful tank possible, ignoring the usual constraints of cost, weight, and long-term production feasibility. The project began in Leningrad, a city still recovering from years of siege and destruction. Within its design bureaus, engineers worked under immense pressure, determined to create a machine that would guarantee Soviet armored superiority in any future conflict. The result was Object 260, later known as the IS-7. Weighing nearly 68 tons, it represented the extreme end of heavy tank design. It was not simply larger than its predecessors. It was engineered to redefine the limits of armor, firepower, and mobility combined. Its armor was not just thick, it was intelligently shaped. Sloped surfaces increased effective resistance, causing incoming rounds to deflect rather than penetrate. The IS-7 turned geometry into a defensive weapon, making it far more resilient than conventional flat-armored designs. The IS-7's main weapon was a 130mm gun derived from naval artillery. This gave it unmatched firepower for its time, capable of destroying any known armored vehicle at long range. It was not designed for parity. It was designed for overwhelming superiority. To operate such a powerful weapon, engineers introduced a semi-automatic loading system. This reduced crew fatigue and increased firing speed, allowing the IS-7 to maintain consistent firepower despite the size and weight of its ammunition. Despite its immense weight, the IS-7 was capable of surprising speed. Its engine, influenced by aviation technology, produced enough power to move the tank at speeds comparable to lighter vehicles, challenging traditional assumptions about heavy armor mobility. During trials, the IS-7 demonstrated remarkable maneuverability. It could navigate difficult terrain with a level of control that contradicted its size, proving that heavy armor did not necessarily limit tactical movement when supported by advanced engineering. Ballistic testing confirmed the effectiveness of its design. The IS-7 could withstand impacts that would destroy other tanks, reinforcing its position as one of the most heavily protected armored vehicles ever constructed. Inside the tank, complexity increased significantly. The IS-7 required a highly trained crew capable of managing advanced systems simultaneously. It was not a simple machine. It demanded coordination, discipline, and technical understanding in every operation. To support its massive structure, the IS-7 used advanced rubber metal track technology. This innovation improved durability and performance, allowing the tank to operate under conditions that would strain or damage conventional track systems. By the late 1940s, military strategy began to change. The focus shifted from building the most powerful individual weapons to creating systems that could be produced, deployed, and sustained on a large scale. The IS-7's size created immediate logistical problems. Transporting such a heavy vehicle across railways and bridges required infrastructure that was not always available, limiting its usefulness in large-scale operations. Production realities further complicated its future. The IS-7's complexity made it difficult to manufacture efficiently. In modern warfare, quantity often outweighed individual strength, and the IS-7 could not be produced in sufficient numbers. Despite these limitations, the IS-7 performed exceptionally in trials. It passed nearly every test it was given, demonstrating superior performance in firepower, protection, and mobility compared to existing designs. Ultimately, the decision to cancel the IS-7 was not based on technical failure. It was a strategic decision driven by changing military doctrine, where flexibility and scalability became more important than individual battlefield dominance. The IS-7 represented the peak of a design philosophy that prioritized maximum capability. It was built without compromise, but in doing so, it also revealed the limits of such an approach in a changing strategic environment. When compared to earlier heavy tanks, such as the Tiger II, the IS-7 surpassed them in nearly every category. It combined thicker armor, greater firepower, and better mobility, making it one of the most advanced tanks ever built. Future designs moved in a different direction. Tanks like the M48 Patton emphasized balance, reliability, and deployability, reflecting a broader shift in military thinking during the early Cold War. As the Cold War began to take shape, military planning shifted toward large-scale conflict scenarios across Europe and beyond. This required forces that could be deployed rapidly and sustained over long distances, placing new demands on armored vehicle design that the IS-7 struggled to meet. Future wars were expected to be fought across vast territories, requiring armored units capable of rapid movement and redeployment. The IS-7, despite its tactical mobility, was limited at the strategic level, where transport and infrastructure became critical constraints. Fuel consumption posed another serious challenge. A tank of the IS-7 size required enormous amounts of fuel to operate, placing strain on supply chains and reducing operational endurance in prolonged campaigns where logistics determined success. Maintenance demands further limited the IS-7's practicality. Its advanced systems required specialized knowledge and extensive support infrastructure, making field repairs difficult and reducing overall readiness in fast-moving operational environments. At the same time, tanks like the T-54 demonstrated the value of simplicity and mass production. These vehicles could be built quickly, deployed widely, and maintained efficiently, offering a more practical solution for modern warfare than highly complex heavy designs. In controlled conditions, the IS-7 excelled. It overcame obstacles, maintained speed, and delivered firepower unmatched by its contemporaries. Yet these strengths were tied to ideal conditions that did not always reflect the realities of large-scale warfare. Military doctrine increasingly emphasized combined arms operations, where tanks operated alongside infantry, artillery, and air support as part of a coordinated system. In this context, individual vehicle superiority became less decisive than integration within a larger force structure. The IS-7's design represented an extraordinary level of engineering sophistication. Every component, from armor layout to internal systems, was optimized for maximum performance, reflecting a design philosophy focused on achieving technical perfection. Today, a single IS-7 prototype remains preserved at the Kubinka Tank Museum. It stands as a silent artifact of a different era, untouched by combat and unchanged by battlefield experience, representing potential rather than history. Unlike most legendary tanks, the IS-7 has no battle record. It was never deployed, never tested under fire, and never integrated into active units. Its story is defined not by combat, but by what it could have achieved. The evolution of tank design after the war moved away from extreme heavy armor. Designers focused instead on creating balanced vehicles that could operate effectively across a range of conditions, reflecting changing strategic priorities. Large-scale armored formations required vehicles that could be produced and deployed in significant numbers. The IS-7, despite its capabilities, did not fit into this model, where scale and flexibility became the defining factors of success. Even without combat history, the IS-7 remains one of the most impressive tanks ever built. Its design pushed the limits of what was technically possible, setting a benchmark for engineering ambition that few vehicles have matched. The IS-7 was created at a moment of transition. As warfare evolved, the definition of effectiveness changed, moving away from individual machine performance toward integrated systems capable of sustained operations across vast theaters. The IS-7 remains a paradox, a machine of unmatched power that never fought. It was not canceled because it failed, but because it succeeded in a way that no longer mattered. It stands as a reminder that in war, timing can matter more than perfection.